Okay. So you've had a chance to look at the units for area and the units for volume and how to convert them, right? And you've hopefully seen the beauty of dimensional analysis and how that helps you do that. Now we're going to actually find surface areas of objects that you're both familiar with and new ones that you haven't worked with before. Okay? So, just for old time's sake, let's redefine what surface area is. Can you tell me in the best explanation that you can conjure what surface area is? What am I talking about when I'm asking you to find the surface area of an object?
Isn't it like times width times height?
Nope. That's what most people say. That's volume.
It's like how much area the surface.
When you add them,
It has to do with adding
all the sides.
yeah, you add all
Added
the
together.
sides.
all the faces
Yeah.
added together.
So like front, back, bottom.
Yeah. Right?
Top.
It's the sum, by definition, it's the sum of the areas of all the faces. Okay? So if you're talking about, like, I don't know, a refrigerator box, and you bought your grandma a new refrigerator for Christmas and you wanted to wrap it, you'd have to figure out how much wrapping paper you needed to cover the surface of your box. And maybe a little bit extra so that you have some overlap to tape it down. But surface area talks about the sum of all the areas on the outside of an object. So, we're going to look at these 6 shapes today. Well, I don't know if we'll get the triangular prism, but we'll definitely look at 5 of them. We're going to look at a rectangular prism. You should already know what that is. It's a box, basically. Triangular prism. You should know what that is because we did those in grade 9. Cylinders should also be familiar to you.
Yeah.
But these ones here, cone, rectangular, pyramid, and sphere, those may be new to you. To start things off, we're going to do a pretty simple example just to review surface area and how to calculate it and stuff like that. I'm going to find the surface area of a rectangular prism. This is an easy object. This should go very quickly and be very familiar. So, John wants to wrap a box of chocolates to give to his girlfriend for Valentine's Day. Brownie points for John. The box measures 24 centimeters by 10 centimeters by 4 centimeters. If John needs 21 centimeters squared of overlap, that's extra wrapping, to complete his wrapping, what area of wrapping paper does he need to cover his box? And what do I usually say before I start area problems or surface area problems? What do I keep saying? Draw a picture. Draw a picture, right?
Yeah.
So let's draw his chocolate box. Okay. So here's a rectangular prism. Yikes. So there is a rectangular prism, and I'll erase these unnecessary parts. So it's 24 centimeters, that's the longest part, by 10 centimeters, that's the second longest part, yikes. And 4 centimeters, that's the height of it. Usually they give dimensions in length, width, and height, so just follow that. What's the surface area? Well, I need the area of all the faces and add them together. So the top and the bottom are the same area. Agree? Disagree?
Mm-hmm.
Yeah. So if I find the area of the top and double it, then I have the area of the top and the bottom. So area of the top is what? How do I find it?
24 multiplied by 10.
24 by 10. That's 240. And then both of them added together?
Where'd you get the 10?
480 from.
What's the 10 from?
Right here. The top of the box is 24 long, 10 wide. So 24 times 10. Okay, so 480 centimeters squared. And I'm going to circle that number. Okay, I circle these values because I'm going to add them all together at the end. After I find all the areas of the faces, I'm going to add them all together so that I have my total surface area. Okay, the front and the back are next. They're also the same. So what are the dimensions of the front?
24 and 4.
The very front of the box, this part right here.
Oh, 10 and 4.
It's 4 high, 10 wide. So 10 by 4. So that's 40 centimeters squared. And is that it?
No, you have to double it.
I gotta double it. Why?
Because there's two sides that have that.
Yeah, the front and the back are the same. So that's 80 centimeters squared. And I circle it. Why?
Because you're going to use it.
I want to save it for later. What two faces have I not calculated yet?
The sides.
The sides. Okay, so I look at the sides. What are the dimensions of the sides?
24 and 4.
24 by 4. So area is, well, I don't want to go red yet.
24.
24 by 4. So that's 80 and 16, 96.
Yeah.
And do I double it?
Yeah,
Why?
because there's two sides. When you triple it.
There's 3 sides to the box.
Yeah, because of. Wait, no.
Okay, 96 times 2 is 180, 192.
Yep.
And I circle it. Okay? So this should be pretty quick, pretty easy. If it's not, you're going to have to spend some time practicing it because you should already know this stuff. It should be like second nature. So to find the total surface area, so I'm going to use SA to represent surface area. I'm going to add all those numbers together. So 480 plus 80 plus 96 to get my total surface area.
Plus 96, you need 192.
Thank you. 192. Okay, and that gives me how much? Somebody?
752.
Thank you.
Squared.
Now, have I done what the question asked me to? Did I do what the question asked me to do?
You did, but you're missing how much he's going to need if he needs 21 centimeters.
I need the overlap as well. Okay, so I got to add that on.
Plus.
Yep. So the actual surface area will be 752 plus 21 for the overlap. So that's 773 square centimeters. And if he buys that much wrapping paper, he will cover his chocolate box and make his girlfriend happy.